Hello and warmly welcome to episode 221. Today is December 13, and today with Holger and Robert we will talk everything and anything related to Microsoft and SAP. Hello.
Hello, everyone.
So today we will talk one of my favorite area, and concrete means concrete example of a concrete customer migration project to Azure. And I'm always impressed, especially that would be an example of an Oracle SAP system of size of 200 or more than 200 terabytes of data. So not gigabytes, it's really terabytes. And when I hear these numbers, I get really scared. I start to ask myself what kind of technology is basically used in Azure in order to be able to chew it. I mean, all this kind of data. How the migration was done, how the migration downtime is minimized. How did you ensure that the performance is really meet the requirements? So all this and more we will talk today with Denny, Sathish, and Anbu, but before who were part of this project. But before we start with the details, let's do a quick introduction. Denny, you are first time here, so please feel free to introduce yourself to the folks who maybe see you for the first time.
Hello, everyone. My name is Denny Koovakattu. I have been in the healthcare industry for a very long time, probably 25 plus years. I am a database architect. My main focus is performance optimization, both at the application and database layer.
All right. Anbu, you are already here, a colleague of mine.
Thank you, Denny. Warm greetings to all of you. My name is Anbu. I'm part of the Azure engineering team, practicing SAP for the last 28 years. And part of engineering team, I have a privilege to work with the top engineering customers. And then most recently, we worked with one of the customer where we solved a 220 terabyte Oracle database, how to migrate to Azure. So I'm super excited to be here. Over to you, Sathish.
Hi, I'm Sathish Thirunethiram. I work with our strategic partnerships team, Microsoft. I'm also an SAP architect. I've been in the SAP world for about 18 years. With Microsoft for 5 years. I help largest customers, Fortune 500 customers, move their SAP landscape to Azure.
So tell us a bit more. I mean, I'm really curious, I love to see, that was a successful project, but generally the devil's in the details, so.
I will start with the session go around where how we engage with the customer, and then how we partner with the customer to get in the conversation of moving their largest and biggest workloads, how we do with a lot of customers, and especially the customer with 200 terabyte, how we interface with them to have the conversation going, to get to a point that to start thinking about moving the workload into Azure. So that's the first step. So I belong to the strategic partnerships team. As part of the strategic partnerships team, we work with Fortune 100 and Fortune 500 customers. So we have the connections with the strong leadership connections from the top, from Satya, some cases from Satya to the Judson connection as well. So where we have the partnership going on between Microsoft and then the customers. Taking that relationship, our team capitalizes on that, and then we go to the customer to have a meaningful relationship. It's not just we are selling something, but we have a meaningful relationship with them to solve their problems. So we go to the customer. We don't quote numbers first. We don't try to sell our products in the initial get-go, but we'll try to understand what the customer's journey is, where they are at in their journey, and we try to help them with their pain points. So with this customer, when they came to us saying that we can't move our 200 plus database anywhere in the cloud or our partners, one of the partner has done an assessment and said this database cannot be moved into any cloud, not only Azure, but any cloud. That's their strong belief, and that's their strong perception, and that advice has been given by the partner, which is a major partner in the industry. So they have a strong belief. So we went there, and then I think Bill Gates said that we in data in God we trust rather than bring data. So we told them, hey, what you're saying is absolutely right, but for the sake of it, we want to look at your data. So give us your data, EW report, AWR report, and then let's go through them and let's squad through them, and then let's take a look at it. If you can't move, we will be upfront with you. If you don't have a solution, we will be honest with you. That's what we told them. And then usually when we go to the customer with respect to Oracle or SAP in general, they are worried about SLA, HADR, and then I will restrict myself to the Oracle and the 200 terabyte database. The main questions I had with them is about Oracle licensing. So how does the Oracle licensing works in Azure? So and then say I have a 200 terabyte database, and what kind of OS I need to be on. So for Oracle perspective, Oracle supports only OEL on Windows, and then how we can support them in getting the OEL or migrate. How does the HA work with OEL for the app servers, and then for the ASES and ERS, that's the SAP message server, where we can run them on SUSE or Red Hat for them to have the HA for their ACS and database. And then the database layer will be protected using the Oracle technology itself. So that's the kind of an architecture we told them they can protect their system. Coming to the IO and throughput. So that's the one which worries a lot of customers. In this case, they were running the IO like multiple like more than 100,000 of IO, and then we have throughput which is ranging about 5 Gbps to 12 Gbps, right? So in some cases, they were running like 10 Gbps, close to 10 Gbps now. So they're saying we have a throughput which is touching about 10 Gbps. How can you run this in Azure? So that's the main question we have to answer then. So
basically you were not, when you, sorry if I may interrupt, when you do the sizing, you didn't just do subs perspective, but actually you had to do additionally in the IO, in the networking bandwidth as well, of course, because it's such a huge system.
Yes. So when we have such a huge system, the SAPs, so we might have a SAPs, like we have a solution like 32 terabyte, which can handle up to like millions of SAPs, but in most cases with Oracle customer in general, more than the SAPs, we need to look at the AWR report and then the EWR report, which tells you how many dialog steps they run, and then how many batch they run. So those are the metrics the customer cares about. So the SAPs is there when you do a real-time implementation. That's important, but in this customers, with respect to Oracle is concerned, basically we look at what the dialog steps, what's your batch step, and we look at their AWR report for Oracle, and then we look at what's your throughput, what's your IOPS. Those are the key factors we look at in evaluating the workload that can be managed in Azure. These are the primary reports. In some cases, with respect to this customer is concerned, we need to look at even their SAN, and SAN is for storage, and SAR is the system activity report, which is collected from the OS. We got that report as well. To identify the throughput, which is measured in the AWR, is also captured in the system level report. What are the channels they're using throughput, and what is going on at the infrastructure layer as well. So we need to capture that and then analyze that before making the recommendation to the customer. So once we analyzed everything, we compared them against the industry peers, which all the customers who have the dialogue steps or the batch steps equal to them or slightly greater to them. So we are fortunate in that perspective. Like my team works with like strategic 100 or Fortune 100 companies. So we have, I would say, 70 to 80% of the strategic customers with us. So that gives us the wide range of customers with the size equivalent to the 200 terabyte customer, or some cases higher than that, right? Even then, the customer who we are speaking with have they are veterans in the field. They have been running SAP for about 20-25 years, so they know their systems in and out. So when they say things, we take customer concerns very seriously. So we work with them to understand where their objection comes from. So it's not that they are saying something for the sake of saying it, but they say it with a reason. So we try to understand that reason, and we try to provide solution to them which will satisfy their requirement. So that's the key. So on looking at the AWR report or the EWA report, so what we came to a conclusion is this workload can be moved into Azure. So how it can be moved, I think Anbu will explain in detail, but I'll give you an overview of that. So basically, what we're trying to do is we analyze their throughput into segments, which is the segment which is mostly throttled in their system, and they were running IBM Power. And then so we want to move them from IBM Power to a VM-based solution in Azure. That's the recommendation we made to them. And then for the storage and the IOPS requirement, we told them we could use ANF, and then we will use the Oracle optimization parameters and stuff to reduce their throughput from 7 to 10 GBps into 1 GBps range. So that because memory is cheap, with the advent of, I tell all my customers, the cloud world is like dog years. So the amount of advancements we make in cloud in 6 months will not be equal to what they will make in other fields. So so we make such advancements. So the memory is getting cheap and cheap. So the increasing the cache and then decreasing the throughput will make their throughput requirements manageable. With IOPS, we have a secret called ANF. The ANF can handle the IOPS, whatever comes in their way. So with that, we propose the initial solution, and then a lot of customers, we don't do a POC or kind of a pilot kind of a thing, because we have a lot of proofs, a lot of things which like benchmarking from other customers, which we can show them to them. But in this customer, it's like a 200 plus terabytes. We need to run a testing before to prove the solution, and then to make that performant in that before making a call to move their system into Azure. With that, I'll turn it over to Anbu. Anbu is part of the solutioning team. I think he is involved with me from the start of the project until it's completed, and then it's still going on. Over to you, Anbu.
Oh, thank you, Sathish. And once we really socialize with the customer and ready to go hit the ground, it just breaks down into fewer infrastructure components. As you can start with a VM, We really need a powerful VM which can host 200 terabyte. What technology underneath that Azure offers to really supplement or help the workload that needs that kind of really whether the CPU power or IO power. Let's talk about that. And prior to that, I'm going to say probably a year back, 2 to 3 years back, we came on a show to talk about 100 terabyte Oracle database. Back then, we leveraged M192. It is our bread and butter SKU for a larger database. It did really well. But over a period, there are a lot of advancement happened. So now we have an MV3 SKU. The MV3 has two innovation comes with it. One is the innovation that comes from Intel. There's another innovation that comes from Azure, which is Azure Boost. So combination of these two is what helped us to really meet the customer requirement. Let's start with really the Intel innovation. Within the Intel innovation, if we take a Cascade Lake, that was really one of the processor that Intel has it for some time. Then from there, they release a Sapphire Rapid. So there is really quite a bit jump in terms of, I want to say really the SAPs. There is about a 15-20% jump in the SAPs. More importantly, there is a huge jump in a memory access. Cascade Lake uses a DDR4 technology where you get about 3,600 million transfer per second. When you go to DDR5, the same thing goes to 4,800 million transfer. There is about a 50% improvement in the memory access. Why is it important? When we come to Azure with such a large database, when you think about a ECC or OLAP workload, underlying, when you really analyze the IO pattern, there are about 70 to 80% of them are really doing a read access all the time. Can we really buffer those read into the memory? Once I buffer to the memory, then I also need a extremely fast memory access for me to really provide that performance that what the chipset can provide. This is where the DDR4 to DDR5 made a really fundamental difference. So going from DDR4 to DDR5, we were able to not only use really the larger SGA buffer pool for a database, also with the technology, we were able to access it fairly quickly. This actually played a huge role, not only just to migrate the workload, even on a performance. That's really number one.
So actually, the 176 SKU approximately has the similar RAM, even a little bit less RAM, but a little bit less CPU, but still the overall performance is better because the CPU is faster and the memory is actually faster, right?
Extremely
which
faster.
Is automatically. And plus you will come, of course, which are quite interesting, the advances in disk IOPS and throughput and network bandwidth, right? Which enables such a huge push to the storage, right?
Absolutely. Let's talk about that one. See, when we had this SKU almost 2 to 3 years back, this had a really different technology. I had about a 40 gig network card under the cover, which is about a 5 GB per second throughput. When you come to this, the latest SKU, it uses Azure Boost. What is Azure Boost? We basically, when you look at the hardware and you put a host operating system, hypervisor, then a lot of work performed in hypervisor in a previous generation. Whereas with Azure Boost, we were able to offload your storage and IO traffic, pretty much all of that activity into the specialized hardware. By doing so, now we freed up the host. That's number one. Number two, since I have a specialized hardware, there my limit is also going up. So the striking difference, as you can see, we're going from 80K IOPS to 130,000 IOPS. We're going from 2 GB to 4 GB. Now I no longer tied to the host to deliver this. Now I have a specialist hardware sitting slightly outside the host. That's what the Azure Boost does. And with this 100 gig, we're able to really get close to 12.5 GB per second throughput. As you can see, the managed disk can get about 4 GB. Network bandwidth get about a 5 GB. Combinedly, you got about 9 GB. But the whole machine sits in its own host. And there, the NIC provides up to 12.5. So it's a pretty big pipe. We were able to open it up with this SKU. That's the innovation come from Azure. So sum it up, there's the innovation come from Intel. There's the innovation coming from Azure. Combination of these two really provided the highest processing power as well as really the required bandwidth. Hopefully that sums it up. Let me go to the next slide. All right, the next critical building block for this is really a storage. All right, we got a VM out of the way. VM is capable of doing what we wanted to do. Then we still have to really make sure the storage layout, which really resonate to support the workload. Over here, what we have done here is We predominantly pivot on ANF, which is really the Azure NetApp files, which really writes through your network interface as opposed to really writing through your IO channel. So over there, we have a well-defined layout. I mean, we'll talk about this. I'll probably give a small demo, which will probably sum it up everything, how this is going to work. And then this is really the first step. Once we got really the bulk of our stuff that we really needed on ANF, then there is also really a managed disk channel that we have. That channel, we leverage it for really hosting the binary, archive file, temp file. And interestingly, temp can also be put on really the temp disk as well. There is also a temp disk comes on every, most of the SKUs, which is really ephemeral disk. By definition, we typically customer use it for swap space. In the case of Oracle, you could use PSAP temp, which is really the temporary scratchpad for the database on ephemeral disk. There's no real business data stored there. Even if your VM reboots, you're perfectly fine. It's only a scratchpad. Think of that as a scratchpad for your database, right? Yeah. That's how this layout was done. I'll pause here, Goran, if you have any question.
Yeah, so basically, on one hand, on the storage side, I mean, the main technology is in ANF here, which is chewing the data and the log files, and can process a huge amount of IOPS and throughput. But also on the compute side, you also need a huge throughput as well, right? In order to be able to push through the VM, you know. So both has to match, you know, otherwise the VM could become a bottleneck in the whole story.
Interesting point. Interesting question. What you brought it up, and then the managed disk offers about 4 GB per second throughput. Your ANF uses the NFS protocol, goes to the network bandwidth that is about 5 gig. Interestingly, the way platform behaves, if managed disk is not utilized, that throughput is also given back to the network throughput, plus what we don't put it out in the public document.
Okay.
Yeah, what we don't put it out in, these are all the things we don't put it out in public document. And then overall, this VM sits in its own host, which has 100 gig network card. So literally, we let it ride up to even beyond what we published in the document. We needed all of that. We needed all of that for this database. So there is engineering. I mean, there is really a thing that's said in the public document. There are things that how it behaves is slightly different. And all of that played a vital role in meeting the IO requirement.
Cool.
All right. Now, how about we just really demo? I mean, it looks a lot of storage configuration.
Yes, please. Yeah.
Can we really do a small demo to, how about if I tell you the whole thing can be laid out in a more systematic template-based approach rather than really creating them manually one by one. So let's dive into a small demo here. So what I'm going to say in a NetApp, everything starts with the NetApp account. I just have one of the NetApp account. Over here, I have a capacity pool already created. And then let's say when you create a capacity pool, the definition is really simple. I'm just going to call it the 200 terabyte. And then basically pick the tier, which basically dictates your throughput. And the most important thing is a manual. We really need a manual to deploy in a template-based approach. So that's the only thing that I'm going to call it out. So since I already created it, I'm going to cancel this guy out. And you do have here the capacity pool already created. Now let's dive into really the creation of the Oracle template. So we use a feature called application volume group. In short, we call it the AVG for Oracle. And then I'm going to add a group, pick the Oracle as a workload. You could also do the same thing for HANA. We have been doing for HANA for a very long time. And Oracle is a new addition. It's really a new addition. And then pick Oracle, go to the next slide. Over here, you basically define how many Oracle data file that you want. I'm just going to put 8 for a time being. I'm going to say that I need about like 10 terabyte, right? And then, so I do have 40 terabyte. I'm going to say 10 terabyte. I'll probably say that I need about 3000 IOPS. Then you can also put some overhead. Typically the Oracle, when you take a snapshot, it just, I want to say the snapshot overhead is somewhere around 3 to 5% on a size. So we'll just put 3% for a time being, or then we'll go to the next step and see what it does. It let you pick the zone, which is zone where you want to deploy. I'm going to pick a zone 1. And it also gives you the option to do a basic network and the standard network. We recommend almost all customers to use standard going forward. It does provide UDR support, NSG support, all kind of latest and greatest security features are you can capable of leveraging them in the standard support. Then we'll pick the capacity pool where we're going to place the volume, which is really like, I already created that 40 terabyte volume, which I'm picking it. Let's go to the next. It's useful to define some tags. I'm going to skip this for time being. Let's go to protocol. This is an interesting one. And it does. We support both NFS 3 and 4.1. And then NFS 3 has been out there for the last 20 plus years. NFS 4.1 is fairly new. It's been out there for a few years. There's still once in a while we ran into really dNFS bugs. As a result, most of our customers are still on NFS 3. If you have really a very large database, want to have a stable solution, I would say stick to 3. You could still use 4.1. There's absolutely nothing wrong. Both are fully supported. But from the experience, I can say 3 is a lot more stable than 4.1. And then that's really the one. Then let's move on. Now, as you can see, it created the whole template with all the throughput. Now you have ability to even go adjust. Let's say I just want to increase this guy to slightly 500. I mean, you have the ability to go adjust the sizes. I mean, you can really adjust the size. You can adjust the throughput. Then you really review and create. It will let you create the whole template in one shot. Yeah. And while it's creating, it's also going to create multiple storage endpoint. It'll distribute the storage nicely into multiple storage endpoint, so you don't create a storage hotspot. So it takes care of all your routine issues that typically we run into, hotspot and all that is taken care in the template-based approach. This is how simple it is.
Yeah. So it does help you to deploy those different storages. You know what exactly you would need to size it, and also on the back end to split the data and log volume, so to say, with the different endpoints, and so they don't have a collision or they don't share the same bandwidth, right?
Absolutely.
Which is a great stuff. And we had for HANA, and now relatively recently we got it for Oracle, which is excellent. Yeah.
Anbu, you said something like dNFS.
I'm going to quickly touch on dNFS, right? So Sathish, a great question there. With Oracle, let's talk about how NFS works. NFS has something called NFS server, then NFS client sitting on a guest operating system. There, typically the kernel NFS is what is used by the NFS client to really push the traffic. Only in the case of Oracle, they took a responsibility of the NFS client, took a software of that, embedded into the Oracle, which is Oracle took a responsibility. By doing so, they're able to work with the server in a most efficient fashion to support the Oracle. This is really a pretty striking feature that actually elevates your throughput, especially the read throughput, pretty significantly. We have a benchmark where dNFS versus a non-dNFS, as you can see that the numbers are pretty significantly higher. So that's a feature that we were able to marry to this solution as well. All right, with that, I think we did a demo. All right, we talked about storage, we talked about compute. Then can we really confirm this solution still meet the customer requirement? Until we do the testing, it's not going to add up whether it's really met the requirement or not. I'm going to invite our friend here, Denny, over to you. Can you please take us through how testing has been done to confirm this architecture really met the requirement?
Thank you, Anbu. So, as Anbu and Sathish mentioned, we have features. We have got a lot of innovation in Azure, which can support the workload. But what's critical is whether we need to understand that it meets our business requirement, right? Can we go to the next slide, please? So before we get started, I think it's extremely important to, be clear about what your goals are. Your goal is not to take something which is on-prem and then move it as is. What I mean to say is, hey, we have doing, 10 gigabits of, IO throughput. I need that in Azure. I'm doing 20. I need exactly that. I mean, you're not going to take it component by component and then put it over there. That's not going to work. You are going to come up with a new solution, right? So you need to understand what your business requirements are. And what you're really trying to see is it going to perform the same or better? And two, you need to also make sure that you have sufficient headroom for growth. So that's your goal. Once you set that, then you need to come up with what is going to be a testing strategy. How do you go about proving that out, right? So you need to first, I think I'll stay on that slide for a little bit longer. So we really need to identify what are our critical windows, right? So what is my peak? And identifying peak is critical. We are always sizing your system for peak. Now, when we look at AWR reports or all that, you're probably having a 15-minute interval where you're capturing snapshots. But within that, there could have been a peak. Yes, that's a good starting point, but you still need to understand what your peak is. And you really need to know what is it that you can tolerate. I mean, you could say that, yeah, I want to average. I mean, it's okay to look at my peak over a 1-minute interval, and my system can support that. Or I've seen OLTP systems where even a 5-second, interval is the more appropriate one for that. So you need to identify what is my critical business window, what is my peak, or and I'm able to measure that. And then you got to think about how am I going to generate that load, and also, test each and every component, and also ensure that it's meeting my business requirements. So I think you are looking at a combination of both synthetic workload plus your actual business workload. One other thing I would also mention is when you're testing it, you want to test your failure. The reason I say that is once you go through that, there are a lot of lessons learned. I mean, I see how each component behaves, and then you can go back and adjust. So test your failure. So I think once you have that strategy put in place, then you start looking at, how do I leverage that? So can we go to the next slide, please? So we used a combination of, Oracle RAT, your application, you have your application testing, you've got different scripts, backup, your jobs, batch jobs, things like that. So there's a combination of that. But the one thing I would say is always focus on the runtime. You really want to make sure that it's successfully finished within that time. One thing you probably will notice that a lot of these components are much more efficient than you will probably see on-prem. So things are going to run faster. You're going to have collisions. So you could potentially have something which used to take 8 hours running in, let's say, 4 hours or 2 hours, and that would potentially be introducing other condition with other areas, because you could have some workload, let's say, you could potentially even have application level locking issues because things are now running faster. So be aware of that scenario. I mean, performance is always better performing systems are always good, but the one side effect of that is you could potentially have, workload collision. So think about that. And then also monitor for contention. So Anbu had mentioned the difference between the V2 and V3, MV2 and MV3 earlier. We actually saw that. We tested it on both MV2 and MV3. And you could see that we actually had much higher contention on MV2. And that's mostly because of the time it takes to access memory. I mean, you are having contention because things are being held longer slightly. I mean, as you are running faster, you are going to start seeing some of those things, that contention happen. So it's extremely important to actually watch out for contention as things start running faster.
Yeah. I believe, Denny, when I see this, what you're presenting is also thinking about, it's not just you want to make sure that applications are performant, users, batch job, but also there are things happening in the background from time to time, backup, reorg, index, which all might influence the live productive system, which is still being used by the user. And you need to make sure that even with those additional activities, still the system is performant enough for the normal task that it should do, right?
Correct. Yeah, all of that, right? We want to test everything which we need for successfully running our business. We need to test all of that. And you also need to make sure that, if you have how these things interact with each other, because you can isolate one portion and test just one area and then realize that, hey, what if I run my backups, it's supposed to run. So what is my strategy there? And we'll briefly talk about some of that. So you run your maintenance jobs, and then, HA. how are you going to implement a check? Oracle Data Guard works great. I mean, we tested out Oracle Data Guard with FSFO, works just fine. And then when it comes to data protection, I mean, backups. I mean, you can offload your backups, especially with your using, Data Guard. You can offload your backups to your standby. So hey, you're not even impacting your primary workload. One thing I would probably also talk about is, this is a challenge we would have, because again, depending on the migration strategy, if you are, let's say, coming from something like AIX to Linux, you're probably going, I mean, from the Power to Intel, you will have to, you're doing a cross-platform migration, and depending on, I mean, especially in the case of SAP, and we will talk about how it was done, but it's essentially a new system. Now, on day one, I mean, once during your go live, you don't have HA, DR, or probably for that matter, backups ready to go. So how do I work around that? So the time it takes to build. I mean, we have got some great strategy. We were able to get all of that done in a few hours. I mean, there are ways to do it. I don't want to get into the details on this, right now, because that's a topic in itself. But these are some of the things to think about. How am I going to work through all of these and then, be ready for the implementation? But overall, what I can say is, it worked better than I would have thought it would, 6 months ago. It just worked just great. I mean, it met all of my expectations and some more. So I would say thanks to, and that was because of the partnership with the Microsoft engineering team, Anbu, Sathish, we had Ralph support us for the end of site. So between all of, it didn't feel like, we were working with, a different team. We were all one team. We were able to implement it without any issue. So thank you. I would say thank you to the Microsoft team for making it happen.
Yeah.
Denny, I mean, go ahead.
This is really fantastic, and I really love how detailed you tested and verified that everything is working. And I also loved what you said in the beginning, that you cannot just compare one-to-one what you had on premise, especially if you are replatforming, basically, if you're coming from a different CPU architecture, if you're coming from a completely different system, but then still doing this very, very detailed test, and also this test to failure to really see where are the limits and stuff. I really, really love the approach that you did there.
Thank you.
Awesome. Thank you, Denny. And we do have a wonderful blog, migrating a 220 terabyte from it's a heterogeneous migration, and the downtime is going to be a challenge. I mean, if I really quickly, we have a blog. We'll put the link in the YouTube channel for others to take a look at it. Imagine if you have to do a standard technical approach coming from SAP, it would have taken 96 hours to do the migration. The customer expectation is less than 24 hours. There's no way we could have done it with a standard approach. So we absolutely leverage a partner approach. There are several partner approach out there. In this case, we leverage Lemongrass cloud platform Migrate approach. That actually resulted in a pretty significant reduction in. That's what we talk about it in the blog that we have it there. So I just want to highlight that there's no way we could have done without the help of the partner, which played a really vital role in getting us done. And if I go ahead.
There are other technologies out there. In this case, we trusted LCP Migrate. They were able to achieve that, but we have other partners as well and other tools as well. And also, this is a very unique case of moving from a big Indian to little Indian. So we need to use the specific deployment approaches, even the Oracle's methodology we have evaluated. So there are other options as well. LCP Migrate is, in this case, we have used LCP Migrate.
Thank you, Sathish. That's awesome. And it's important. I mean, there is no way we can really, complete the project without having a good migration strategy. And last one, the most important one is all right, we are on Azure. We still need a very strong data protection strategy, especially when it comes to ANF. Majority of the things are running in ANF. Can I leverage a snapshot? That's really the super critical one. By having a snapshot, we no longer put any workload on a ding on the running database, the primary database. It takes about like a seconds or less than a minute or so, and you got the backup done. That's how quick it is. At the same token, At the same token, we still have to have a really incremental backup or a full backup taken over the weekend or everyday basis. That in this case, we leverage the data guard. Basically, we let that run on a HA standby instead of running on a primary. By doing so, we were able to achieve both quick. I'm going to say that this is going to provide you the business RTO. What if once in a lifetime, if you ever have to go back in time, you have at least a snapshot to go back fairly quickly. Or what if I have to really restore for a complaint 30 days old, for whatever it is, your retention periods are, there you really need a really the weekly backup and daily incremental backup, all of that. So we have kind of covered both aspects of it. So that's how it is. If you really want to look at it from the restore failure scenario standpoint, snapshot and log happens in a minutes. Oracle backup with the Orman backup with the log, it can take about hours. So that's the worst case scenario. So we have both case covered. Similarly, on a whole region going down, we still have to really make sure if the whole region is down, how am I going to really get my database, my business up and running? So you have Oracle Data Guard, which basically like replicate your data all the way to your really the DR region, where you can really like bring it up in no time. I mean, it's really synced up to your production and then pretty much kept up with your production real time with a really a minute support. And with that small RPO, we were able to get that one validated as well. In a worst case scenario, I still need a really a version backup restored. So there is a technology underneath, and then we really replicated the version backup to the remote region as well. So you have an option to even restore the version backup as well. This is how the customer have a complete data protection strategy, which is super critical, especially for the very long data, very large database. It can take hours to restore. We had to have really a perspective around it to say, what is the business expectation? What is the technology that we are going to apply? I think with the sleek, I want to say the snapshot out of ANF is a strikingly really a contrast right there to help the customer to get the numbers.
And these kind of, yeah, go on.
It's just not in the paper. Denny speak about the test. Denny ran about, I don't know, 20-25 tests in a 200 terabyte database. So every time he tests it, he puts it back. So those all happened in a matter of minutes. So he had like three databases, I think, 3 or 2 databases in parallel. Then he did a lot of awesome work with Anbu. So Anbu tried to help with setting it up, and he tested it really thorough.
So you did a lot of restore tests as well.
Yes,
absolutely.
It's and this is crucial for the downtime of the SAP system, right? So if you are able to restore it quickly, it's mean you have minimum down in a quick time, a minimum downtime, which plays a crucial role for the business continuity.
Correct. And I'll finally sum it up with the last slide. This is how the architecture has been deployed. We have a primary region, zone 1, zone 2. They are really distance apart. I mean, of course, 2 different fault domain. And then near zero, it's really literally like RPO 0 over here. And RTO somewhere less than 5 minutes. We were able to achieve with this simple architecture orchestrated by the Oracle, data guard with FSFO. Using that technology, we were able to achieve that. And by extending that Oracle data guard to the DR region, we were able to get RPO somewhere close to like 15 minutes under, which is pretty typical for most of the large customers. And then, of course, RTO is going to be really in a hours range. I mean, a few hours range, and it's pretty compelling. I mean, this is really a well-tested architecture what we implemented over here in this customer. All right. I mean, what I'm going to say in my summary, I'm going to say this. Look, we dream of thing that we ever did it in Azure, and then at the same time, we have to be practical about how we approach it and realistic about what we are going to deliver. And then there's no way we could have done this without the great partnership coming from our customer base particularly. And then customers have that patience and then temperament to work with us. And we were able to push the envelope in every case. And we pushed the envelope 100 terabyte 3 years back. Now we are able to push 220 terabyte after 3 years. It just sets a precedence that what is our next number could be. It is really what customer wants, and we're absolutely willing to partner and go do and make it happen.
And with this customer, we have the largest customers, the largest database in the public cloud on SAP. It's all running in Azure.
Yeah.
That's really
I mean,
cool. And Anbu, I think this is your invitation to come back in a year from now with 300 terabytes, or I don't know.
300
There you go.
episodes and 300 terabytes. Ambu, I don't want to see anything less below,
There you go. I take the challenge. I mean, let's put it that way.
Yes.
Goran and Volgan, we are taking the challenge, and then we dream of doing things that we never did it. And I think it's the thanks goes to the customer base who are trusting us, and then we are also able to go meet them where they are at and understand their position, and also able to be realistic about what we have and how can we get there. I think that's where the rubber hit the road.
Yeah. I mean, when I hear the 200 terabytes, I got dizzy, I thought maybe it's a gigabyte, no, it's a terabyte, and just to really all these detailed tests, which basically everybody must do, I mean, you never know, but sometimes I do see, or in the past, long experience, they're not properly done, and then you go live and then suddenly surprises, simply because you haven't tested, when I see also the HADR, I mean, like 10 years ago, that was a science fiction. It was too expensive. Now it's becoming a commodity, It's just a commodity, which is amazing, So guys, really love the story, and I'm happy to host you, all of you, this time. And again, Ambu, and Denny and Sathish, well, let's put the challenge 300 and above, Terrible. Really happy to have you guys.
Thank you. Thank you for having me.
Thank you, Volga. Thank you, Goran, for having us.
And see you some next time. See you. Bye.
Thank you.
Bye-bye.
Greetings.
Bye.